So the C function is another function that can be used to create vectors of objects. And you can think of C as kind of as standing for concatenate, because it can be used to kind of concatenate things together. So for example, I can create an object called x by concatenating 0.5 and 0.6, and that will give me a numeric vector of length 2, where the first element is 0.5 and the second element is 0.6. In the second example here, I've got a logical vector where I'm concatenating true and false. So shorthand for true and false, you can use T and F, capital T and capital F. So these two lines give you the same object. You can create a character vector by concatenating a bunch of characters. You can create an integer vector by creating a sequence with the colon operator. And you can also create a vector of complex numbers where the I is a special symbol which indicates the imaginary part of the complex number. So using the vector function, you can also create a vector of a certain type and a certain length. So here I'm going to create a numeric vector of length 10, and by default it will initialize the vector with a default value. And for numeric vectors, the default value is 0. So what happens if you take if you create a vector and you mix two different types of objects? And so the general rule is that R will kind of create the least common denominator vector. So it will not give you an error, but what will happen is that it will coerce the vector to be the class that's kind of the least common denominator. So here in this first example, I've gone from concatenating the number 1.7 and the letter A. So clearly these are not of the same class. One is numeric and the other is character. So the least common denominator here is going to be character. And so what you're going to get is that Y is going to be a character vector where the first element is going to be the string 1.7, and the second element is going to be the letter A. So in the second example here, I'm concatenating true, which is a logical, and 2, which is a numeric. And so what's going to happen here is that you're going to get a numeric vector, and the true is going to be converted into a number. And so how does that happen? And by the convention in R, true is represented as the number 1, and false is represented as the number 0. And so what you're going to get here is a vector 1, 2. Lastly, this last example here, I'm concatenating the letter A and the logical true. And so here the least common denominator, again, is going to be character. And so the vector that you end up with is the vector where the first element is A and the second element is the string true, so T-R-U-E. It's not going to be illogical. So you need to be a little bit aware of the types of coercion that can occur in R when you mix different types of elements in a vector. And because you won't get an error, but the coercion will happen behind the scenes. In the previous slide, we talked about a kind of a implicit coercion that occurs behind the scenes, but you can explicitly coerce objects from one class to another using functions that usually start with the word as. So for example, if you want to convert something to a numeric, you can use a function called as.numeric. And if you want to convert something into character, you can use the function as.character. Now, if you apply these functions, so if you apply as.numeric to a numeric vector, nothing will happen. So here in this example, I'm starting off by creating an object called x, which is a sequence of 0 to 6. So this is an integer sequence, as you can see when I call class on the object. But I want to convert it into a numeric sequence. And so I can call as.numeric on x, and you can see that it prints out 0, 1 through 6, which looks like an integer object, but it's actually going to be numeric. Or I can convert it into a logical. And so I can say as.logical on it, and what happens? Well, as you can see, the convention is that 0 is false, and any number that's greater than 0 is going to be true. So here I've got, when I convert to logical, I get false, and then everything else is true. When I call as.character on x, it takes all the numbers and converts them into characters. So now I've got the string 0, the string 1, 2, etc. And finally, if I call as.complex, this is fairly straightforward because you can all it does is says that you have a complex number where all the imaginary components are 0. Now, coercion doesn't always work, and when it doesn't work, you get what are called NA values. So nonsensical coercion will result in NA. So for example, if I take the vector ABC and call as.numeric, well, there's really no way to convert the letters A, B, and C to numeric variables. And so what you'll get is a vector of NAs and plus a warning. Similarly, if you call as.logical on x, you're going to get a vector of NAs. Matrices are a special type of vector in R, so they're not a separate class of objects, but they're basically vectors that have an attribute called the dimension. So the dimension attribute is an integer vector of length 2, where the first number is the number of rows of the matrix, and the second number is the number of columns. And so if I can create a matrix, an empty matrix with the matrix function, and I can explicitly say how many rows and how many columns there are. This is not the only way to create a matrix, but it's one way. And so when I auto-print the matrix by typing the object M and hitting enter, you'll see that it'll show me that, first of all, the matrix is initialized with NA values, so there's no values in here. And you can see that there's 2 rows and 3 columns, and they're labeled by the numbers in the brackets. If I call the dim function on M, it'll give me the dimension attribute, which in this case it says there are 2 rows and 3 columns, because the first row is the number of rows, and the second number, the first number is the number of rows, and the second number is the number of columns. If I call the attributes function on M, you'll see it returns a list where the first element is the dim element, and it has the vector 2, 3. So these are all aspects of a matrix, which is a vector that has a dimension attribute to it. Matrices are constructed column-wise, so you can think of the matrix taking a vector, and all the numbers are inserted into the matrix by columns. So the first column gets filled, and then when you hit the maximum number of rows, then the second column gets filled, and the third column, etc. So if I create a matrix by taking the sequence 1 to 6, and then I specify that it has 2 rows and 3 columns, well, how does this matrix get constructed? So the way it gets constructed column-wise, so the first thing that happens is it takes 1, 2, and now there's only 2 rows, so it can only go to 2, and then that makes the first column. The second column is made up of 3, 4, and then the third column is made up of 5 and 6. You can also create a matrix by creating the dimension attribute on a vector. So for example, I can create a vector that's a sequence 1 to 10, and then add the dimension attribute to it. So here I'm using the dim function, but I'm assigning a value to the dim attribute of M. So here I'm assigning the vector 2, 5. So what I'm saying is I want to take this vector and transform it into a matrix that has 2 rows and 5 columns. And so now after I've done that, I've got a matrix M which has 2 rows and 5 columns, and it's filled in the matrix column-wise. Another way to create a matrix, and this is a common way, is by binding columns or binding rows. And so this is column binding and row binding can be achieved by the functions cbind and rbind. So for example, suppose I have the 2 objects, x, which is a sequence from 1 to 3, and y, which is a sequence from 10 to 12. If I cbind those 2 objects, then I'll get a matrix where the first column is 1 to 3, and the second column is 10 to 12. So this is kind of what you might expect would happen. If I rbind those 2 objects, then the first row will be 1, 2, 3, and the second row will be 10 through 12. So cbinding and rbinding is another way to create a matrix. The next data type I'm going to talk about is the list. Now I mentioned lists a little bit earlier in this lecture, and the idea is that they're like a vector, except that every element of a list could be an object of a different class. So that makes lists very, very handy for kind of carrying around different types of data. And they're very useful in R, and they become very common, especially when in conjunction with other types of functions that we're going to learn about. So here I'm creating a list called X using the list function, which can be used to construct the list. And the first element is a numeric object of 1. The second element is a character, letter A. Third is a logical, and the fourth is a complex number. So this is not a problem with lists. And when I auto-print the list, you'll see that it prints out a little bit differently. It doesn't print out like a vector because every element is different. So you can see that in the double brackets here, so the elements are indexed by double brackets. So the first element is the vector 1, the second element is a vector with A, the third element is a vector with true, and the fourth element is a vector with the complex number 1 plus 4i. So lists are indexed. You'll notice that elements of the list will have double brackets around them, and elements of other vectors just have the single brackets. So that's one way to separate a list from other types of vectors.